computer science is probably not the first field that they associate with the EV space. But I'm a PhD student here in the computer science department, and I'm sort of representing our lab and the research that we've done in the EV space. And I'm going to try to talk about sort of some of the tools that we bring from our computer science background and specifically networking background that we have been applying to solve some problems in this space. So generally there's 4 things that we do a lot of in our lab. The first of which is modeling. So for example, a problem that we're looking at now is with these lithium air batteries possibly coming and larger batteries in the works. If I were to introduce, say, a battery of 500 miles of range into the EV ecosystem, how would this change everything? Pretty much everything is dependent upon the battery. The range, obviously the range, the adoption rates of customers is going to increase if the range of the battery increases. The cost is going to change as a function of the battery. Distribution networks will have different loads on their transformers because they'll have higher range or larger batteries. Charging is going to be affected. Pretty much everything is affected by the size of the battery. So we're trying to model this system, model all these parameters to answer questions like, if we were to introduce, batteries of higher range, how would each of these pieces be affected? Another thing that stems from our background in networking is control theory. So if you have a system and you want to find out how to make this system run optimally, how should you sort of turn all the little tuning knobs in this system? So something that we've been looking at recently, we just had a paper in this space, is if you want to come up with a charging algorithm for, say, a whole bunch of EVs that does not rely on a centralized node. So what a lot of people have done in the research space when they talk about charging algorithms is they assume that everyone's going to upload their demands to some central node. This central node is going to run this giant optimization problem looking at what everyone needs, and then it's going to schedule how to charge all these vehicles. The problem with this approach is that it's a very centralized approach. You need this central node in the sky that knows about everybody's data in order to produce this. So what we're using is some techniques from networking in order to come up with a decentralized approach to charging. So I submit a little bit of data to this node, and they don't necessarily need to know about everything else. We sort of work the way the internet works, where we throttle people's charging rates up and down until it converges to a nice optimum for both the distribution side and the customer side. Another thing that we do often is optimization. So we were working on a project last year with a student that has now graduated and went on to Stanford. If you had a fleet of EVs, for example, you operate a fleet and you have a lot of EVs, and let's say you have some renewable energy. So you have some wind and you have some solar. How can you buffer the renewable energy sources that you have using your fleet of EVs, but also ensure that any charging deadline for your fleet is met? So you want to buffer the renewable energy in the most efficient way possible, but you also want to ensure that the charging contracts of, let's say you have a deadline of the next morning, I want all my cars to be charged. How can you sort of do both of these in the most efficient way possible? And this turned out to be this giant optimization problem. And so what I'm mostly going to talk about is the data side of things. And I know that there's a lot of distribution companies here and things like this, but I am actually working in the space of adoption, customer adoption barriers. So the first talk that was here today sort of took all my, I don't need to even talk about this slide because it was perfect introduction to this. Essentially, we have 2 main barriers. We have the range anxiety problem, and we have the price problem. So what's interesting to note with the range anxiety is it's not just the fact that people think that there's going to be, I'm going to run out of range on my way to, say, Tobermory or what. There's other problems in range anxiety. An interesting one that I found when I did this large literature survey is that people are worried about emergencies. So you get home from your day at work, you plug in your car at dinner time, and then all of a sudden your child is sick and they have to go to the hospital, or something else happens and you need to leave your house. Well, if you have a dead EV in your driveway that's currently charging, you're not going to be able to leave. And unless you have a second car, you're sort of going to be out of luck in this scenario. And another one that was mentioned that I found really prevalent in the research that I did was that the perceptual problem about the public charging stations is a big one. People don't need it. all the data that we have looked at suggests that people do not need public charging infrastructure for the vast majority. But people want it. It's a perceptual problem when they drive around and they see that we've been spoiled by this giant gasoline networks where we have gas stations across from gas stations on top of other stations, and they're just everywhere. And we've been spoiled by this. So people take their EV out and they see absolutely no charging, and they get very worried that we're entering this different paradigm here. And finally, with the price barrier, it's not just that there's a high initial price. We know here that many people can probably make back the high initial price plus more based on the fact that gasoline is far more expensive than electricity. But the problem is, at the time of sale, these payback calculations are complex. People need to know about their usage patterns, and people need to compute how many long trips they take versus short trips versus the weather, and people are not able to compute all of these sitting there in the dealership. So the return on investment is sort of questionable at the time of purchase, and people don't know whether or not it's worth it. So I'm just going to briefly talk about 3 projects that we've done that are sort of in this space. So the first is, this is before I knew about Cross-Chasm, but it's sort of a different model anyway. Back in 2010 and 2011, Better Place was getting a lot of hype. They've now ousted 2 of their CEOs in the past few months, but their model is pretty interesting. Their model is essentially, don't pay for the battery, lease all of the batteries, and we're going to build this network of switching stations where essentially allows people to pull into the stations, switch out their battery, and then drive off. So we were wondering if this model is actually viable for something like, say, a taxi company. This is a futuristic sort of thing, but Better Place this year, just last month, or this month, even though they're going under this massive shift in their personnel, they said that the Bay Area will see its first switching station by the end of this year, and they are planning to introduce electric taxis into the Bay Area. So a couple of years ago, we obtained data from Yellow Cab San Francisco. We had data for over 500 of their taxis, 24 hours a day for a few months. And this data included whether or not there was currently a fare going on in the vehicle. And we had data for over 400,000 fares. So these were regular gas cars. These were not electric vehicles. But we wanted to see, what if these were electric vehicles? How would they have done revenue-wise? So what we had to do is we had to model these cars as if they had batteries. We had to sort of estimate, based on the drive cycle data that we were measuring, the battery levels of these taxis at all times. We measured the fuel, or we estimated the fuel displacement. We estimated if the range was going to be empty by a certain point in the day. What was the revenue loss from the missed fares that they would have incurred at the end of their trip? We did this optimization problem where we figured out if we had the capital to build a few switching stations, where should we put them? This heat map here sort of shows, this is the San Francisco, this heat is the airport down here, which is not actually in the heart of the city. And this might be hard to see on the projector, but as expected, most of the mass is in downtown. So we actually took this data, ran an optimization approach to determine where should we put these infrastructure. And finally, we also modeled how many batteries should you put at these stations based on the customer demand of people coming in and out. This is a giant queuing theory problem, another computer science derivative of computer science, and we modeled the batteries required. So our goal was to compute a revenue analysis of all of this, both of the cost of the cars, the cost of the fuel, electricity, the stations, the batteries, and we wanted to answer, should the company, as they replace their current vehicles, because the taxi cab administration in California states that they have to be replaced every 4 years. So as they start phasing out their old taxis, should they start buying EVs? And we found that at the time that we ran this, the EVs were just becoming on the profit, they were just crossing that profitable scale if this model were to work and if we had switching stations, because the cost of gas has been so high in San Francisco and electricity has been relatively stable. As another example of a project, this is what I'm currently working on. So we've mentioned the fact that when you go into a dealership, you don't go to Montreal very often, right? Or you don't go to Tobermory or whatever very often. But people are there in the dealership and they think about, well, that 1 year that I want to go to on my vacation, if I buy this car, I'm not going to be able to. So I'm not going to buy this car because I can't take vacations with it. So we had an idea, and we're not sure yet if the idea is going to be integrated into, if it will be integrated into dealerships, rental agencies, or sort of a community idea. we had this idea that when you bought an EV, sort of there would be a pool of gasoline cars available to you somewhere that you can use for longer trips. So for example, if you go to buy an EV at a dealership, I'm not sure that a dealership will be able to incorporate this due to insurance reasons, but there's several benefits if this could be incorporated there. What's that?
It definitely can be. So BMW is launching it. Almost your idea, exactly.
All right, skip slide.
Definitely does. It's a great idea because that's exactly, they're gonna, just like they do if your car goes into the shop.
Exactly.
They'll let you borrow a gas car if you want to go to Montreal for the weekend.
They don't know how to optimize the amount of...
No, they're
So-
not doing this complex. They're just gonna say, here, you can come once a year and borrow the car.
So we were thinking, right, so we were thinking they'll give you some sort of coupon booklet when you buy the car. They can integrate this into the price of the EV so you don't even see it. It's sold as free. This will increase EV sales and you get to use a car from their lot. So the dealership, they already do this sort of servicing when you bring in your car, or they'll give you a loaner car when you bring in your car. But what if something like a rental agency or something like Community Car Share, which is formerly Grand River Car Share, in the Waterloo region wanted to integrate this? So we are solving the sizing problem. If you have a certain population of EV owners and you know a few things about their patterns or how often they're going to need vacations, we can actually use some queuing theory and some interesting statistical methods to say, how many cars should you have per each EV owner? And so Grand River Car Share, Community Car Share now, has just given me all of their data since they launched in 2005. And they're very interested in this idea. So I just received this data in the mail yesterday. So I'm very excited to start looking through it. And I'm going to try to work with them to see if this is something that they would be interested in. So we're working on the sizing problem right now. Lastly, this is my last slide. There's been two real ways to gauge the customer perception of EVs in the literature. The first is field trials. Field trials are very expensive because you have to buy the vehicles and you have to have enough vehicles to give out to all of the people in order to run the field trial. You have to monitor them, then you have to take the cars back and give them elsewhere. And because the cars are expensive, you can't really buy too many of them, right? The second is there's been like Deloitte and there's been huge companies that have essentially interviewed drivers as to their driving habits. But what you're doing when you do this is you're interviewing people that are not EV owners about their perceptions towards EVs. We're interested in knowing how do EV owners actually view their experiences with their vehicles so far. So if you were to search essentially whatever myleaf.com or myvolt.com, you would essentially come up with millions and millions of reviews. Just the number of sources of reviews is so large that no one prospective buyer can go through it. So we're essentially writing this automated data mining system that will take this giant database of EVs and start to answer questions about it algorithmically. So some interesting questions, let's say we download millions of reviews, or forum posts or discussions. These don't have to be just reviews. How do opinions temporally evolve? For example, does range anxiety increase as a driver has their vehicle for longer, or does it decrease? We can look at our opinions correlated with other trends. So how high does gas have to get until people really start buying more EVs? People generally know about this trend, right? But we can actually start to answer by looking at the data just exactly how these trends are correlated. What are the authoritative sources of information? If I'm a prospective EV buyer and I go on my leafownershipforum.com, there's millions of posts on here. There's way too much data to go through, and even more so, there's more sites. There's green car reports, there's consumer reports. Where should I look to find the best source of information? So we're essentially reducing the amount of not spam, but irrelevant information in this entire review space down to a smaller set of information that a prospective buyer would look at. And finally, something that we're very interested in is that we can provide personalized recommendations. So if you tell me what you're interested in as far as a spec of your vehicle, you want range or you want whatever features of the vehicle that you're interested in, and you tell me that and you give me your pricing requirements as to what you want, I can run your request against this giant database, and I can have the system sort of put out, these are the vehicles that people would recommend if you were to tell them that these were what the specifications were, and these other vehicles would not be so well according to the reviews. So these are the questions that we are trying to answer by mining EV reviews. So hopefully I've presented some ways that we can use this data analysis approach in the EV space, and I know that a lot of this work that I'm doing is on the customer adoption side, but as we all know, getting off of oil will be a multi-domain approach, so we need the distribution side, we need the generation side, we need the customer side, so thank you.
Already, it doesn't present those problems. How do you mind that and present it in a way that's not going to give you privacy issues?
So all of the data that we've received has been from outside sources. I think the issues that Royden was talking about is that we wanted to do some of our own monitoring. We wanted to build a smartphone application and essentially deploy this out to people, gather their data, and then analyze it. We haven't run into that issue yet because we've gotten our data from companies. So for example, Grand River Car Share, I just had to sign an NDA with them that says I won't release it, but I'm able to publish all results derived from the data. And I don't need to go through ethics clearance from that because I'm not collecting the data myself.
So as long as you're doing an aggregate response versus individual, then you can...
Right. So we don't have personally identifiable, I know the driver IDs, but I don't know where they live, I don't know who they are. I only know what they're using the Grand River vehicles are for. And the taxi data that was released to us, and these EV reviews, for example, these are public. So we do have the same sorts of issues, it's just that the data sets we've looked at so far, with NDAs and such, we haven't run into this quite so much yet.